Alright, so hi guys, give me 1 second. Alright, so I hope everybody is doing well. So in this video, I want to go ahead and go over a problem, in calculus, right, that involves integration. Now this problem, I will admit, I made it way harder. Like, I actually did a method that was much more difficult than the method that they actually used for this one. Now, I want to say prove that integral of secant x cosecant x dx is equal to the natural log of the absolute value of tan x plus constant integration c. Now, here's the thing, guys. Like I said, I made it much more difficult than I thought. So here we're gonna go ahead and rewrite using trigonometric identities. This is gonna equal the integral of 1 over cosine x, so that's the first part here, and then times cosecant x, which is 1 over sine x, right? So you kind of have to use your reciprocal identities here. So we have to understand trig identities. So now, and then dx over here. So now let's go ahead and just put this into one fraction. The integral of 1 over sine x cosine x. And then since the dx is being multiplied on top, we're just going to put dx right here. Now, here is where I want to say, oh, and actually, I'm sorry. Let's put 1 here. So we're going to go ahead and then I'll put dx on the other side. I don't want to put dx on top yet because really this is we need to do a little special trick here. Here's what I saw that they did. They converted this into sine squared x plus cosine squared x equals 1. This is much easier to do. What I actually did in my situation was I multiplied the top and the bottom, I believe, by cosine x, and then I did use substitution, and then I did integration by parts, and then finally at the very end I got logarithmic expressions, and I expanded with logarithms, and then I did trig identities again. I'm sorry, I condensed with logarithms, I did trig identities again, and then I got ln of absolute value of tan x. But we're not going to do it like that, okay? We're going to go ahead and rewrite, so we're going to say integral of sine squared x plus cosine squared x, and then over sine x cosine x. Now we're going to just go ahead and rewrite this as sine squared x over cosine, over sine x cosine x. Actually, yeah. And then plus cosine squared x over sine x cosine x. So this is the integral, and then with respect to x. Now, you want to kind of use your properties of exponents, guys. You're going to do integral of, it's going to go sine x over cosine x plus, and actually dx. And then it's going to go plus the integral of cosine x over sine x dx. Now, if you do have, so now here's the thing, if you do have your table of integrals, that's good. I want to show y'all another thing here that I think, give me 1 second, guys. So this is the integral of tan x dx plus integral of cotangent x dx. Here's the thing, guys, and if y'all want me to, I will go ahead and show y'all the detailed explanation for tan x. This is integral of sine x over cosine x dx plus the integral of cosine x over sine x dx. Now, in this part, we're going to use u substitution. So u is going to be sine, actually, I'm sorry, u, give me a second, is going to be cosine x, and then du, I believe, will be sine x dx. I'm sorry, negative sine x dx, excuse me. So negative, give me a second, guys. Okay, guys, so I went ahead, so I'm doing the first part here, okay? So you just use u substitution. Du, u is cosine x, du is negative sine x dx, dx is negative du over sine x. Substitute it. This is going to cancel out. Oops, this is going to cancel out. And you get the integral of negative 1 over u du. I'm going to go ahead and put that there. And then this is going to be, and then we're going to do plus integral of cosine x over sine x. Now, for this one, I believe now sine x will be u, so u will be sine x, and then du will be cosine x dx. So this one's a little easier, because we don't have to do any, like, manipulation here. This is going to be integral of negative 1 over u du. Actually, let me put the u in yellow. Plus, it's going to be the integral of du over u. So du over u. Actually, I'm sorry. It's supposed to go du. Oops, sorry, guys. Oh my goodness. Okay, so sorry about that, guys. It crashes on me every now and then. So this is going to be du, and then over, and then u. Okay, now move this negative outside, so negative integral of 1 over u, in other words, du over u, plus integral of du over u. I do apologize, Jesus. Okay, so it's integral of cosine x over sine x dx. So, okay, this first part, I'm making it this, actually, let me put, so this part is u, right? So, or I'll put it as u here. So u is cosine x, so this part stays the same. I'm sorry, guys. And then on the next part, what we're gonna do is, this one is gonna be, I'm gonna do it as v. So here v is gonna be sine x, and then dv is gonna be cosine x dx. I do apologize, guys, for that. So it's going to be the integral, so negative the integral of 1 over u, or negative, I'm going to do negative, I'll do negative du, actually, wait a minute, I'll do negative 1 over u du. And then plus, and then this part is going to be the integral of dv over v. So again, guys, I apologize. We had to make 2 different substitutions for these two. I did u and v because it's just better that way. And then at the end, I'll substitute it after I integrate this. So then we're going to do v is, it's going to be plus 1 over integral of, it's going to be dv, so dv over v, right, over v, which is, so now what we're going to do, we're going to say negative ln of absolute value of u plus natural log of absolute value of v, at least I think, right? And then this is gonna be, give me a second, of v, and then this is gonna, if you kind of like use properties of exponents, you get ln of absolute value of v minus ln of absolute value of u. And then, and of course you would say plus constant integration c. Here's the thing, guys. This is going to be ln of the absolute value of v over u, right? So it's going to be ln of absolute value of v over u. Okay. We're almost done, guys. I'm so sorry for that mistake. And then give me 1 second, and then plus constant integration c. Now again, v was sine x, u was cosine x, okay? So if you look previously, we said v was sine x, so v was sine x, u was cosine x. And then here, we're just going to say ln of absolute value of sine x over cosine x. And then plus constant integration c. So then remember that sine x over cosine x is tan x. So this would be ln of absolute value of tan x plus constant integration c. And that is the integral to cosecant x, secant x, guys. I do apologize if this took me a minute, or not a minute, but probably 20 minutes, actually 13 minutes. But if anybody does have questions, please let me know. And thank you all so much for watching. And again, happy holidays to everybody. And please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.